Good morning, Algebra 1. Mrs. Latham here. We are on week 6 of our distance learning. Today is May 11th, and this week we're going to be looking at section 6.4, which is applications of systems of linear equations. So, the first thing I want to go over is when do we pick each method? So for graphing, it's normally when we want a visual display, or we want to estimate a solution. So we didn't have much practice with this, but a majority of the time, we're going to actually get decimal or fractional answers. So if we're graphing a system of linear equations, like if we're looking at the one to the right, it's not lining up nicely. It might be 1, -1, but it's not perfectly on the middle. Like if it was supposed to be that point, it should be moved over more here, but it's not. So it's really to estimate a solution, but most of the time in math, we don't want to estimate. We want a concrete number. So realistically, when are we going to use graphing? Not a lot. The second method is substitution. So we want to use substitution when one equation is already solved for one of its variables. So that is this example down here. Notice that y is solved for. It is 3x. So we can actually plug in 3x in for y, right? I could do x plus 3x is equal to -32. And then I could solve that, but I'm not going to. Or we could do it when it's easy for one of the variables to be solved for. So this is the second example. And if you notice in the second equation over here, y could be solved for. And to solve for y, we could add 2x on both sides. And when we do that, we get y is equal to a positive 2x minus 3. So now it's very easy. We can substitute and bring it over. The last method is elimination. That's what we spent last week learning. And so we want to use elimination when the variables are the same or opposites. So I forgot to put an example, so I will give you one. So that would be something like 2x plus 4 is equal to 8 and -2x minus 5 is equal to 12. So in these ones, what's really important is the 2x and the -2x are opposite, so we could add those together. Just to show you, another example would be something like 3x minus 2y is equal to 7 and -5x minus 2y is equal to 1. So again, in both of these cases, we have a -2y. So in this case, we would have to go ahead and multiply one of the equations by -1, but we still can add these easily. Now, the second statement says, when it is not convenient to use graphing or substitution. So we did not practice this, but just to kind of show you guys, that would be when you have a really, really messy one. So say we had -3x plus 2y is equal to 12. And then say we had 6x plus 14y is equal to 20. So looking there, they're both in standard form. We cannot easily solve for a variable, and they're not like easily to cancel out. So this is an example where we'd have to use elimination. And what we could do is for this specific problem, we could actually multiply the top equation by 2. And when we do that, my x term is going to become -6x, and it'll cancel out nicely with this 6x here. Just to give you guys an idea of when we would like to pick methods. And this is going to be really important because this section looks at word problems. And when you go to write your equations, you're going to have to determine, do I want to solve using substitution or elimination? So let's actually look at some practice. So it says without solving, so we don't have to solve these, What method would you pick to solve and why? So if I'm looking at the first one, the first thing I notice is in both of these equations, a variable is solved for. So I'm going to go ahead and say substitution. And why? Well, it's easy because y is solved for. So I would say y is solved for in both equations. Now we only need y to be solved for in one equation, but this actually makes it nice. Okay, for the second one, if I'm looking, I don't have any variables solved for. Each variable has a constant in front of it, right? 3, 4, 3, 2. So I can't easily solve for one, so substitution's out of the way. But now I know for a fact that if I'm not using substitution, I'm going to be using elimination. But the question is why? Well, if we're looking, I have a repeated number. I have 3x and I have 3x. I could multiply one of those by -1 and add them so that x's will cancel. So I could say 3x and 3x can cancel out. Okay, and then for the last one, I like that color better. Let's look here. I have 4x minus 3y, and then I have y is equal to -2x minus 1. Well, right off the bat, y is solved for, so I'm going to automatically go to substitution. And why? Well, y is solved for in the second equation. And there we go. We figured out our plan of attack. We know which method we're going to use and why. So let's actually put this to use, doing word problems and solving. So a fashion designer makes and sells hats. The material for each hat costs $5.50. The hat is selling for $12.50 each. The designer then spends $1,400 on advertising. How many hats must the designer sell to break even? So the first thing I have to think about is, what are my variables going to be? What is changing? So from what I can see, let's look at the last sentence. That's normally where we're going to get our variables from. So it says, how many hats? Well, I don't know how many hats, right? So that has to be one of my variables. So I'm just going to go ahead and say that x is going to equal hats. We don't know how many. That's what we have to figure out. And then it says, must the designer sell to break even? Well, I don't know what break even is either. Now, for those of you who don't know what break even means, that means that you want the amount you're spending and the amount you're making to be the same number. So if I bought material for $100 and then I made something with it and my profit was $100, I broke even, right? I spent $100, I made $100, I didn't gain any money, but I didn't lose any money either. So we broke even. So that's going to be my second variable. So now we have to write equations for these. So I'm thinking, okay, material cost $5.50 per hat. So I could write an equation that says $5.50 per hat. And I'm thinking, well, $5.50 is what I'm spending. Is there anything else in this word problem that talks about spending? And the answer to that is yes. Right below it, it says spends $1,400. So we spent that money on advertising, so that doesn't affect my hats, but it affects my break even. So I'm not going to put a variable with it. I'm just going to add it. Now, what is this going to equal? This is going to equal our break even, right? We need to figure out how much everything cost, how many hats we made, plus advertising to break even. So that's the first equation. The second equation, we're going to look at my profit. So if I go back into my word problem, it's telling me that they're selling for $12.50 each. And there's nothing else in here that gives us a value. So that must be our only form of profit. So that means if I want to break even and I'm selling $12.50, it's going to be $12.50x because that's how much the hats are. So if you look at these two equations, they're both solved for y. So I'm going to pick substitution to solve for. And I'm going to bring this over because I'm going to solve off to the right. So I'm going to substitute 1250 x in for y in my top equation. So I have 1250x is equal to 550x plus 1400. So I know that I have to subtract 5.5x on both sides. We're going to get 7x is equal to 1400, right? These canceled. Divide both sides by 7, and x is going to equal, let me see, 200. So we have to sell how many? We have to sell 200 hats. Now let's go back into the word problem, right? It says, how many hats must the designer sell to break even? So what's really important about this question is we don't really need to know what the break even number is. We know it exists, we could find it, but the question's mainly focusing around how many hats. So sometimes when you get an equation like this, we don't have to go further. We can just stop. So for this, we're just going to stop. We found our answer, and the answer is 200 hats. Okay? Now, that's using substitution. I want to show you guys an example of elimination and how that one would work. Normally, when we use elimination to solve for, you will have to solve for both variables. So it says, Emily and Alicia are selling flower bulbs, tulips, and roses for a school fundraiser. Emily sold 1 package of tulips and 11 packages of roses for $218. And Alicia that says solved. It's supposed to be sold. 10 packages of tulips and 12 packages of roses for $318. What is the cost of each package of tulips and roses? So we're going to have two equations again. I have to define my variables. So let's go back to the question. It says, what is the cost of each package of tulips and roses? That's our variables. So tulips, I'm going to make x. It doesn't really matter which one you make, x or y. And then I'm going to make roses my y. So now I'm going to write two equations. Well, I'm thinking, Emily's selling flowers and Alicia's selling flowers. So they must have their own equation. So if I'm looking to solve for Emily, I'm going to do her in blue. I'm going to look at that second equation. It says Emily sold 1 package of tulips and 11 packages of roses for $218. Well, if I use my variables, I'm going to have my 1x plus 11y, and the total is $218. If I look at Alicia's, let's do it in like a green color. She sold 10 packages of tulips, 12 packages of roses for $318. So she's going to be 10x plus 12y is equal to 318. And if you notice, this is kind of one of those messy ones, right? None of my variables are going to cancel, but that's okay because we can we can work around that, but we're not going to use substitution for this. So if I'm looking, I think the easiest method here is going to be multiplying my first equation by -10. And the reason behind that is I want to cancel it out with the 10x on the bottom. So when I do that, we're going to get -10x plus 11y. Oops, we're multiplying here, so it's going to be -110y is equal to 2,180. And then I'm going to add this to my 10x plus 12y to get my 318. So we're going to add these. We know that the 10x's are going to cancel. I'm going to get -98y is equal to, and that should also be negative, and I'm going to pull out my calculator for this. So sometimes we're just going to get numbers that we can't do it in our head, and that's okay. So -2,180 minus 318. And we get, oops, we're supposed to be adding that. $180, and then it's going to be plus 318. Okay, and we get -1,862. Now I'm going to divide both sides by my -98. And I'm going to get that my y value here is 19. So that's telling me that roses are selling for $19. But we want to know the cost of both prices. So we're going to have to go ahead and solve for tulips. So what I'm going to do is I'm going to go back to my first equation because x has a 1 in front of it. I think that'd be easiest to work with. And I'm going to plug in 19 for y. So I'm going to do that here on the right. So 1x plus 11 times 19 is equal to 218. So 1x plus, we're going to do 19 times 11, and we get 209 is equal to 218. We're going to subtract 209, and we're going to get that 1x is equal to 9, or x is just equal to 9. So that means the cost of tulips is $9. So we found the price for both, right? Tulips is $9, roses are $19, and that is our fundraiser. Okay, for this week, you do have your practice questions. I thought I updated this so it said week 6, but I guess I forgot. Actually, this is all wrong. I apologize. So let's look at this. So due on Wednesday, which is going to be 5/13 by 3 p.m., you're going to have your week 6 online learning slides due. It's just a couple questions. You have 3 questions where you need to figure out what method you're going to use, and then you have 2 word problems, very similar to the ones I did in this video. Then due on Friday the 15th by 3 p.m., you're going to have a 6.4 practice, and you also have Khan Academy, which I've posted already. If you have any questions, please reach out to me. I am holding D Channel live class this morning at 10:15, and then F Channel's live class will be on Wednesday. Okay, if you guys have any questions, please reach out, and I hope you guys have a wonderful week. Bye.